Good morning, everyone. Today I will introduce the experimental principle and experimental apparatus of the blow fan test rig. The purpose of this experiment is to understand how airflow rate, pressure, power, and efficiency change under different operating conditions. In this experiment, we measure several important parameters including airflow rate, static pressure, dynamic pressure, total pressure, input power, and fan efficiency. By adjusting the damper opening while keeping the rotational speed constant, we can observe how the fan performance changes at different operating points. A blow fan is a type of fluid machinery. Its operating principle is to convert mechanical energy from the motor into kinetic energy and pressure energy of the air through the rotation of the impeller. As a result, a pressure difference is created between the inlet and outlet, which drives the airflow through the system. The experimental setup consists of several main components. First, the blow fan test rig, which provides a stable airflow system for testing. Second, an electric motor and tachymeter, which are used to drive the fan and measure the rotational speed. Third, a damper adjustment device, which controls the airflow rate by changing the opening area. Fourth, a pitot tube or an anemometer, which measures air velocity and is used to calculate the airflow rate. Finally, pressure measuring device such as a U-tube, manometer, or a digital differential pressure gauge are used to measure static pressure, dynamic pressure, and total pressure. Electrical instruments like a wattmeter, ammeter, and power meter are used to measure the input power. Based on the experimental data, we can draw several performance curves, including the pressure flow rate curve, the efficiency flow rate curve, and the power flow rate curve. The results show that as the airflow rate increases, the pressure generally decreases, while the efficiency first increases and then decreases. There is a specific operating point where the efficiency reaches its maximum, which is known as the best efficiency point, or BP. In conclusion, this experiment helps us better understand the relationship between airflow rate, pressure, power, and efficiency in a blow fan. Thank you all for listening.